All right, so hi, this is a video for section 8.3.1 and 8.3.2. And here we're doing confidence intervals for a population mean when the standard deviation is unknown, and we are going to use RGuroo. All right, as I explained in a previous video, the confidence interval, it's always the point estimate, which is the mean, plus or minus a margin of error, all right? So this question is asking me the margin of error. So I'm going to use the calculator on RGuroo, Desmos calculator. To find the margin of error, we need to find the critical value. And the critical value, it's coming from the t distribution because we don't know the standard deviation of the population. We're going to multiply that times the standard deviation of the sample because we don't know the standard deviation of the population. And we are going to divide that over the square root of the sample size. All right. So that's the formula that we need to find the margin of error. So let's see how we find all of this. To find the critical value. To find the critical value, again, we need to find the student t distribution. The student t distribution is in our analytics. No, in our probability simulation, because we need our calculator. So we need the probability calculator for a continuous random variable. All right. We are going to be finding values, so we need to change this to probability to values. We are going to change our distribution to student t. All right, and then here, the degrees of freedom is defined as our sample size minus 1. And I'm going to write this in here. It's defined as sample size minus 1. So you have the formulas. So I'll go here. Degrees of freedom is the sample size. So we have, suppose that the number of square feet per house are number distributed with a known mean and a standard deviation. So again, we don't know the standard deviation of the population. So we need a standard deviation of the sample. We have a random sample of 22 houses. And then that sample give me a sample mean of 1,500 square feet. And it gives me a sample standard deviation of 151. We're going to use RGuroo to find the margin of error for a 95% confidence interval. So we need to find that critical value. Critical value is coming from the student t distribution. Degrees of freedom is sample size minus 1. So sample size is 22. 22 minus 1 is 21. And the other thing that we need in here is we need to find the between tails or outside tails. So outside tails, we need to find, so we have a 95% confidence interval. So we have a 5% left to divide in between the two tails. So we need, we have 2.5 and 2.5 for each of our tails. So 2.5, it's 0.025 as a decimal and 0.025 as a decimal. I'm going to do the graph so you can see what we're doing. All right. So this white area in here, it's 95%. All right. And then this yellow thing plus this yellow area, both of them add up to 5%. So I have 2.5 here and 2.5 here, which is this 2.5 that you see in here, but in the decimal. So the critical value is going to be 2.08. Right. So then we go here to find the margin of error. We are going to do 2.08, which is the value that we found for the critical point. That is going to be multiplied by the standard deviation of the sample, which is given to be 151. And we are going to divide this over the square root of the sample size, which is 22. All right. I have this because I cannot do ME, so I'm going to delete this, but we are finding the margin of error. All right. So the margin of error seems to be 66.96. So I need 2 decimal places. So then the margin of error is 66.96. All right. So again, to find the margin of error, this is the formula that you need all the time. It's the same. Critical value times standard deviation over sample size. The critical value for the margin of error for the confidence interval when the standard deviation is not known. So we use student t distribution. To find that value, we go here. And we pretty much do the same that we do with the tails, same that we do with the normal distribution. All right. The only difference in here is that you need to calculate the degrees of freedom. So the degrees of freedom is just your sample size minus 1. Okay. All right. So then now I need to calculate the confidence interval for this. So I'll go to analytics. I'll go to analysis, mean inference, one population. Same as we were doing before when the standard deviation was known. So then here I have all of the information that I have. I have a random sample of 22, so sample size is 22. I have a sample mean of 1500, so sample mean of 1500. And I have a sample standard deviation of 151. So sample standard deviation 151. Before we were completing this because we knew the population standard deviation. We don't know that now. We're working with the standard deviation of the sample. We are finding a 95% confidence interval. So we are good in there. And our method is not a Z statistic anymore. It's going to be a T statistic because we are using a student's T distribution. We have to label this. I'm going to call it square fit. And we calculate this. We have an output very similar to the one before. So then it 2 decimal places. So 2 decimal places will be 1433.05. And then the next one would be 1566.95. Right. And again, this is the lower 1433.05 and the upper 1566.95. All right. Another margin of error. So then we go back here. So we see what we were doing before. So for the margin of error, again, we need the critical value, the standard deviation of the sample, and then the sample size. So if I go here, I need all this information, right? So the critical value, we need to find it. We're going to do that in a minute. The standard deviation of the sample. So now we have suppose that the scores of a standardized test are normally distributed with an unknown mean and standard deviation. A random sample of 21. So there is our sample size. Scores is taken and gives a sample mean of 95 points. So sample mean of 95 points. Sample standard deviation of 8 points. So then we know that the standard deviation is 8. We need to find a 95% confidence interval. Again, this 95% is what you need to find that alpha. So if I go to the calculator to find again that critical point, the degrees of freedom is sample size minus 1. So sample size is 21 minus 1, that's 20. And the tails are exactly the same because we are working with a 95% interval. 100 minus 95 is 5, and then 5 divided 2 is 2.5. So I have the 2.5% in each of my tails. Again, we don't write the percent, we write it as a decimal. So I do this. with the graph, and it changed a little bit. I mean, that's expected because it's, the degrees of freedom are very close. So our critical point is 2.09. So we go back here and we write the 2.09 for our critical point, and our margin of error rounded to 2 decimal places is going to be 3.65. 3.65. And there we go. Right. Next. Same problem. Now that we found that the margin of error was 3.6465, just from with rounding, we need to find the confidence interval. So if we go here and we open our mean inference for one population, we write what we know. So again, we know that the sample size is 21. We know that the sample mean it's 95. And we know that the sample standard deviation is 8. I'm going to label my variable. We are calculating a 95% confidence interval. And again, the method, when we don't know the standard deviation of the population, is a t. We calculate this, and we have a lower bound of 91.36 and an upper bound of 98.64. All right. And so with that, we have that 8.3.1. All right, so then now continuing on with section 8.3.2, again, we are in the same kind of situation. We want to find the confidence interval for the mean when the population standard deviation is not known. The only difference now is that we are given data sets. All right, so same as before, I'm going to download this. And so I'm going to start here by importing that data set. So I'm going to choose that from my download folder. I'm going to change this name to heart rates. There we go. To heart rates. I upload this. Again, we don't need this. I'm just closing it. And then I'm going to close in here, and I'm going to the analytics, the analysis drop down, mean inference for one population. I am going to choose that data set, heart rates. I need to choose my variable. Right, when you choose the variable, it automatically put the label in here. Same as like a previous video that I showed for when the standard deviation is known. The RGuroo calculates the sample mean, the standard deviation, and the sample size for you. This is asking us a 95% confidence interval, so this is good. So whenever you don't have information to complete this box, you go with the t statistic. If you know the population standard deviation, then you have a number to plug in here, and you use the z statistic. When you don't have the population standard deviation, you don't have information to complete this box, you do a t statistic, right? Other than that, it's the same. We click the blue eye, and we have our interval in here. So 91 point, so we're going to round to 2 decimal places. So that's 91.31. And then the second one will be 95.17 because of the rounding. All right, I'm going to do one more. Okay, so again, we have the number of times test tubes can be heated. We have a sample of 22. We don't have any more information because everything is going to come from the sample. And we are going to construct 95% confidence interval for the population mean. So again, I'm going to download. I'm going back to RGuroo. to import that data set. So I choose the file. I'm going to change this to something that I can is test. It's the number of times for the test tube. So I'm just going to do that. We're going to upload. Again, I don't need this. I'm going to close it. And so I go to analytics. I go to mean inference and one population again. I'm going to select that data set. Going to select my variable. Again, sample mean, sample standard deviation, and sample size is all done for me. The label is done for me. I'm going to change this to a 99% because that is what it's asking us to do. Again, it's a t-statistic for the method because we don't know the standard deviation of the population. We hit the blue eye and our confidence interval goes from this 1071.76. We run it 2 decimal places, and that's pretty much what we have in here. And 2 decimal places for 1477.33. We hit submit, and that is it. So again, that's what you need to do to find the confidence intervals. One, you have the data sets. So if you have any question, just send me an email.